Hello class, we're about to start section 4.3, graphs of exponential functions. An exponential function is a function in the form f of x is equal to a times b to the x, where a is not equal to 0, b is greater than 0, and b is not equal to 1. The constant b is called the base. Now I took the liberty of filling out the y values here. But to get these values, all you would need to do is to substitute these values in the calculator. So you would take 2 to the negative 3, 2 to the negative 2, and so on. Now I did add in another point here that you could add at the bottom. After 3, you could put 4 for x, and then your answer would be 16. Now, after you get these points here, we will plot it along this graph here. Now, if you notice with this graph here, where you plot these points at, it goes up like this here. It's not a straight linear line, and it never touches the x-axis. So you need to pay close attention to that, because later on we will discuss why it never touches the x-axis for this particular graph. Now, we scroll down here to g of x equals 3 to the x. Now, what we would do here is we would do like we did in the previous problem, substitute in negative 3 for x and type it in your calculator. Now, if you notice here, you will have some repeating decimals, and I put the repeating decimal bar over the numbers. Now, after you put in these numbers here, you need to graph them, and of course, the graph will be approximates. So what we have here is our graph. And as you see, we have our arrowheads that signify that this graph goes on forever. Now, I would have written these numbers out, but it's something wrong with this box where the numbers skip. So this is why I took the liberty of filling this out earlier. And then also with this graph here, when I tried to put a graph on the graph that was provided, it also skipped. So this right here is the answer. Now, there's one other little thing about this graph that's a little off, but this graph is supposed to go through these points. So just make sure when you draw your graph, you put your graph through the points, and it's not supposed to touch the x-axis. Now it says note, when the base b is greater than 1, we have exponential growth. The graph is increasing, reading left to right. Now if we look here at this graph here, if we go from left to right, it's going up. And if you notice that it's going along the x-axis is increasing, and also the y-axis is increasing here. It says the x-axis is a horizontal asymptote. Now, what the word asymptote means that this approaches. That means the graph approaches. But never touches the x-axis. As you see how everything is disappearing and skipping, that's what it would have done had I tried to do this graph by hand. But the horizontal asymptote is when a graph approaches but never touches. And in this case, it's the x-axis. It approaches it but never touches the x-axis. Now the domain. If you look at the domain, if you notice, as this graph goes up or as this graph goes along, you're going to have every x value, because this goes on forever and it's not going up in a straight line. It's still going to keep tilting out. So the domain will be from negative infinity all the way to positive infinity. Now it says the range. Since our range here, if you notice, our lowest y value is 0. So our range actually is a little bit above 0. So our range is from 0 to positive infinity. If you notice, if we look at our graph, because it would never touch the x-axis, we would never hit 0 on the y-axis either. So then this would be 0, and we don't hit the negative values either. So this would be 0 to infinity. If you notice here, we start here, not exactly at 0 on y, and we keep going up. So it'll be 0 to infinity. Now, just to clarify something here, when we do the domain, we look at the left side values, and we also look at the right side values. Now from the left, you notice we include all of the numbers from the left and all of the numbers from the right with our domain. Now with our range, we typically go from the bottom, which will be our first value. I'm going to abbreviate this to BOT. That's the bottom, and the infinity is the top, which is our second value. So the question is, what is the lowest it goes as far as the bottom is concerned? It goes just before you hit 0. That's why we have 0 in our parenthesis. And as far as the top goes, if you notice with this arrowhead, it goes on forever. So that's how we get infinity. So now we scroll to the second page. It says for each exponential function, fill in the table of values and draw a graph. Now I added in one more spot, which was -4. And if you substitute in -4 for x, you would get 16. And all of the rest of the values, you would get these values notated here. So after all these values have been inputted, what you would do is graph on this graph here. And if you notice, we would start here at the -4, 16 and graph our points. And then we would draw our graph here. Now remember, the graph is supposed to hit all of the points that you plot here, but of course by drawing it freehand you may miss a point. So this is the graph, and if you notice we have the arrowhead showing that it goes on forever and it never quite hits the x-axis. So the x-axis is the asymptote. Now we come here with the 1/3 to the x power. You notice here we will substitute in our values from -3 to +3, and these are the values we would end up with. And we also have some repeating decimals here. Actually, there is one more repeating decimal. Let me see if I could get it. Now, as you all see, you see how that jumped down. That is why I didn't hand write these values in. But we know that this is supposed to go above the 3 to show a repeating decimal. So please do that in your notes. Okay, now we plot these points and we draw this graph. Again, this graph gets very close to 0 but never touches. So it says when a base of b is greater than 0 but less than 1, the graph is decreasing. And we also have exponential decay. The graph is decreasing reading left to right. If we look from left to right, and we're talking about the y value here, if you notice we're going down from left to right, so it's decreasing. Now, the x-axis is a horizontal asymptote. You notice that it never quite hits the x-axis. So that is the horizontal asymptote. And as we said earlier, it approaches it but never hits it. Now the domain, those are the x values. Now if you notice here, with these arrowheads, that means that to the left is going to keep going out left, even though it's going to be a slight tilt, but it's going to hit every last number from the left. And then also when you see this arrowhead here, it's going to hit every number from the right. So what we have here is negative infinity and infinity. Now the range, if you notice here, it never quite hits the y-axis at 0. It doesn't go negative, but it never quite hits the y-axis at 0. So then our range would start off at 0, which is not included. That's why we add a parentheses. And it will keep going because as you see here, the arrow is going up. And it would keep going up. So that's how we get the positive infinity. So that is our range from 0 to positive infinity. Now, we scroll on to the next page. It says, question, what is the role of a in an exponential function f of x is equal to a times b to the x. So now it says let x equal 0, find f of 0. Now we know f of 0 actually represents our y value. So we have f of 0 is equal to a times b to the 0 power. Now this will give us a times 1, which is a. So we have f of 0 is equal to a. Now if we wrote this in the ordered pair, we know that this 0 would represent x and a would represent your y value. So this right here gives us the y-intercept. So the definition, 0 comma a is the y-intercept of the graph. So when we're asked what does a give us, a basically tells us what the y-intercept is. Now we could use a couple other examples. Let's say we had g of x is equal to 2 to the x. Now if you notice, we don't have an a showing here, right? So when we don't have an a showing here, this is assumed, this 2 to the x is assumed to be 1 times 2 to the x. Because we know 1 multiplied by anything does not change it. So if you don't see an a value, you assume that it's being multiplied by 1. So 1 is your a value. So if we made x 0, we would have 1 times 2 to the 0 power. And we would end up with 1 times 1, which is 1. So your g to the 0 is equal to 1. And your ordered pair would be 0, 1, which is still the y-intercept. Now we scroll down here to the next question. Question, how does b affect the table of values of an exponential function f of x is equal to a times b to the x? Now if you look here, if we go down here to f of x equals 2 to the x, if you look here, from here to here, that's a value of multiplied by 2. If you multiply 2 times 1/8, it'll give you 1/4. If you multiply 1/4 times 2, it will give you 1/2. And 1/2 times 2 will give you 1. So our pattern here is everything here is being multiplied by 2. 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. Okay, so now we look over here. We have our base of 1/3. So if you notice here, we're being multiplied by 1/3. 27 times 1/3 is 9. 9 times 1/3 is 3, and so on. You'll be multiplying each one of these values by 1/3. So now we scroll down here. It says definition. In the table of values for an exponential function, if the x values increase by a constant amount, then the y values are related by a constant multiplier. In other words, for an exponential function, f of x is equal to a times b to the x. If the x values increase by 1, then the y values are multiplied by the base. For a linear function, f of x is equal to mx plus b. If the x values increase by 1, then the y values are added by the slope. So basically in this situation, your b will be basically your slope. So now we go to example 1. State the y-intercept of the following exponential functions. We have f of x is equal to 8 times 2/5 to the x power. Now we know this is the same setup as ab to the x. And we already know that this will give us our y-intercept to be 0, comma a. So we know a is 8. So our y-intercept is 0, 8. Now we come here, g to the x. We have the same thing here. We know our y-intercept would be negative 13. Then we come here, c. You notice we don't show an a, and I told you when you don't show an a, your y-intercept will be 0, 1. But we have our b to the x.